In this video, we're going to do some extra practice with the radical equations and solving equations that are in quadratic form but may not necessarily be quadratic. So let's start with a radical equation. So here's one with two radicals. So the first thing I'm going to do is isolate one of the radicals. Okay, I'm going to isolate for this square root of 3x plus 7 one. Okay, it doesn't matter which one you do. So I'm going to move this other one to the other side. Okay, so that's going to give me square root of 3x plus 7 is equal to 1 minus square root x plus 2. Okay, now we can square both sides of the equation. So that's going to give me on the left-hand side 3x plus 7, because the square root and the square are going to cancel. And on the other side, I'm going to have to expand using FOIL. So 1 times 1 is 1. And then I'm going to have 1 times negative the root, and then another negative the root times 1. So I'm going to have 2 of these roots. And then at the end, I'm going to have plus the root squared. So it's going to be negative square root of x plus 2 times negative square root of x plus 2. So that's going to get rid of that square root as well. So that's going to be 3x plus 7 equals 1 minus 2 root of x plus 2. And then this is going to be plus x plus 2. Okay. Now I want to isolate the other radical. So I still have a radical. So I want to isolate that. So I'm going to move everything else over. So I'm going to subtract 1, subtract x, and subtract 2 to move them to the other side. So it's a minus 3 and a minus x in total on that side. So those go away. So that's going to be a 2x and a plus 4 on this side equals negative 2 root of x plus 2. Okay, now again, I'm going to square both sides. Okay, so on the left-hand side, I'm going to have to expand this out. So it's going to be 4x squared plus 8x plus 8 more x, so plus 16x, and then plus 16 from 4 times 4. And then negative 2 squared is 4. Square root of x plus 2 squared is just x plus 2. Okay, so now I'm going to move everything to the left. So if I expand this, I don't want to do it like that. So I'm just going to have an extra step here. So 4x plus 8. Okay, so I want to subtract those. So minus 4x. Okay, minus 8. So I have to do that on both sides. So that this side's going to be a 0 now. So then I have 4x squared plus 12x plus 8 equals 0. So now I can take out a 4, and then I have x squared plus 3x plus 2 is equal to 0. And now I want to factor this. So I want two numbers that multiply to give 2 and add to give 3. So that's going to be 2 and 1. Okay, so now the zero product property means that one of these factors has to be 0. 4 cannot be 0. Okay, so that means x plus 2 is 0 or x plus 1 is 0. So that means that we get x is minus 2 or x is minus 1. Okay, now we're going to want to check these. So I'm going to do that in a different color. So let's do the check on the side here. So let's check negative 2 first. So I want to plug that into the original equation. So that's square root 3 times negative 2 plus 7 plus square root negative 2 plus 2 equals 1. So this is square root negative 6 plus 7 is 1. negative 2 plus 2 is 0, equals 1. And square root of 0 is 0. Square root of 1 is 1. So I get 1 plus 0 equals 1. So that's true. So x equals negative 2 is a solution. Now what about x equals negative 1? So it's going to be square root 3 times negative 1 plus 7 plus square root of negative 1 plus 2 equals 1. So we're checking to see if that's true. Negative 3 plus 7 is square root. That's going to be a 4 inside the square root. And then over here I have a 1 inside the square root. Okay, so that's going to be 2 plus 1 equals 1. Okay, that does not make sense. So this one is extraneous. Okay, so that means that our solution set just contains the solution negative 2. Okay, so the negative 1 was extraneous. Okay, so that's our solution there. Okay, I think the next one we have is in quadratic form. So we can see here that if I let u be x to the 1/3, okay, then x to the 2/3 is x to the 1/3 squared, because you'd multiply the exponents. So that means that it's u squared. Okay, so that means that 4x to the 2/3 plus 7x to the 1/3, and then I actually am going to subtract this 2 over to put it on the other side. Okay, minus 2 equals 0 is going to be the same as 4u squared plus 7u minus 2. And now we can factor this. I just want to keep that separate. So I want two numbers that multiply to give 4 times negative 2. Okay, so let's write multiply 4 times negative 2, so negative 8, and add to give 7. So that's going to be positive 8 and negative 1. So now I split up this middle term into two terms. So it's 4u squared plus 8u minus 2. Okay, so that 7u became these two terms. And then we do the factor by grouping. Okay, so I group those two. So I can pull out 4u from the first two, and I'm left with u plus 2. From the second two, I can just pull out a minus 1, and then I'm left with u plus 2. And now I can factor out the u plus 2, and I'm left with 4u minus 1 equals 0. Okay, so that means by the zero product property that u plus 2 is equal to 0, or 4u minus 1 is equal to 0, which means that u is negative 2, or u is 1/4. If I solve for u there. So now we want to go back to x's. So that actually means that x to the 1/3 is negative 2, or x to the 1/3 is 1/4. So then if I cube both sides to solve for x, this means that x is equal to negative 8, or x is equal to 1 over 64. Okay, now I don't really have room here to check. Okay, but I'm just going to write check these. Okay, they should both work when you check them. So these are, both solutions. Okay, but you should check them to make sure. But I think that they both work. Okay, so let's try another one. So I wanted to do this one. So there's two methods to do this one, and we only did one of the methods. So we can also do this one by clearing fractions. So let me just turn into that blue color. So I'm just going to write it again down here. So it's 1 over x minus 2 all squared minus 3 over x minus 2 equals negative 2. Okay, so what I mean by clearing fractions is we can multiply by the least common multiple of these fractions. So that's going to be x. So if you look at all the denominators here, I have x minus 2 squared, x minus 2, and just 1. So the common denominator is actually x minus 2 all squared. So if we multiply both sides by that, okay, then this one's going to cancel. Okay, this one's going to cancel with one of them. So I'm going to end up with 1 minus 3 times x minus 2 on this side. And here I'm going to have the whole thing because there was no denominator there. So now I have no more fractions, so I just want to expand everything out. So it's 1 minus 3x plus 6 is equal to negative 2 times x squared minus 4x plus 4. So that's 7 minus 3x is negative 2x squared plus 8x minus 8. And I'm going to move these things over so that I have a 0 on one side. Okay, so then I have negative 2x squared plus 11x and then minus 15. Okay, so that means I want two numbers, okay, so that multiply, actually let's do it down below here. So I want to multiply to negative 2 times negative 15. So multiply to 30 and add to 11. Oh. Okay. So that's going to be 6 and 5, right? Multiply to 30 and add to 11. So now let's take this up here. So I can factor. So I have negative 2x squared. Let's do plus 6x plus 5x minus 15. And then we do factor by grouping. So I can pull out I'm going to pull out negative 2x. So then I have x minus 3. And here I can pull out a 5. So then I have x minus 3. And now I can pull out the x minus 3. And I'm left with negative 2x plus 5. Okay, so that means one of these has to be 0. So x minus 3 is 0, or negative 2x plus 5 is 0. So that means that x is equal to 3, or if we solve this one, x is equal to 5 over 2. Okay, same as before. So we already checked them. Okay, so these would be the solutions. Both of them worked. So that's just another way that you could do the same problem. So lots of different problems here have multiple ways that you can solve them. So let's try a couple more. So here, again, there's multiple ways to do this. I'm going to kill off the denominator, so like what we just did. So that means I'm going to multiply both sides by x squared minus 1, because these two multiplied together gives me that. Okay, so on this side it's going to cancel out right away, and on the other side I'm only going to get one of the terms. So this is going to be negative 4x times x plus 1 plus 4 times x minus 1 equals negative 8. And now I just want to expand. Okay, so maybe I should be a bit more clear about that. So this is x minus 1 times x plus 1. So when we multiply by the first term, you can see that the x minus 1 is going to cancel with the x minus 1, and that's why I just have the x plus 1 here. And then over here, the x plus 1 is going to cancel with the x plus 1, so that's why I just have the x minus 1 there. Okay, now we just need to expand everything out. So negative 4x squared minus 4x plus 4x minus 4 equals negative 8. So I'm going to add 8 over so that I have a 0 on that side. And then I have negative 4x, the 4x squared, sorry, those go away. And then so I have a plus 4 equals 0. So I can factor out a minus 4. And then I have x squared minus 1. Okay, which factors? This is a difference of squares, so it's x plus 1 times x minus 1. So one of these has to be 0, so x plus 1 is 0, or x minus 1 is 0, which means that x is negative 1 or x is positive 1. So those are our possible solutions, but when we check them, you can see almost immediately that they're not going to work, neither of them. So when I put in negative 1, it's negative 4 times negative 1 over negative 1 minus 1 plus 4 over negative 1 plus 1 equals negative 8 over negative 1 squared minus 1. Okay, so this is 4 over negative 2 plus 4 over 0 equals negative 8 over 0. Okay, so these things are bad. Okay, so this one is extraneous. Okay, and it's similar for x equals 1, so I'm going to leave that for you. Okay, so this has no solutions because both the possible solutions were extraneous. Okay, let's try this one. So I'm going to start by moving the 36 over so that I have a 0, because it tells me the hint here, factor by grouping. Okay, so I'm going to try to group them into these groups. So from the first two, I can take out x squared, and I'm left with x plus 4. From the next two, I can take out minus 9, and I'm left with x plus 4, because 9 times 4 is 36. Now I can factor out the x plus 4, and I'm left with x squared minus 9. This is a difference of squares. The x squared plus minus 9. This part here is a difference of squares. So it factors as x plus 3 times x minus 3. And then I know that one of these has to be 0. So x plus 4 is 0, or x plus 3 is 0, or x minus 3 is 0. So I get x is negative 4, x is negative 3, or x is positive 3. And in fact, all of these work. So our solution set contains all of them. So that, all right, we have 3 answers for this one. Okay, I think there's one more to do here, down here. Okay, so I gave you a note here when we did the first video that you don't want to divide by x if possible. So to avoid that, what I'm going to do is subtract this guy. I'm going to put everything to the same side. Okay, so then I have x to the 5 minus 4x cubed is equal to 0. So now I have a common factor. So I can take out x cubed, and then from the first term I have x squared left over, and from the second term I have a minus 4. And now this part is a difference of squares. So I can factor that as x plus 2 times x minus 2. And now each of these 3 things, so x cubed, x plus 2, x minus 2, one of them has to be 0 in order to equal 0. So we get x cubed is 0, or x plus 2 is 0, or x minus 2 is 0. Now x cubed is only 0 when x is 0. X plus 2 is 0 when x equals negative 2. And x minus 2 is 0 when x equals 2. Okay, so, and all 3 of these work if you plug them in. So our solution set has 3 numbers in it. So 0, -2, and +2. So if you did divide by 0, or sorry, divide by x at the beginning, you would have still, or x cubed, I guess, you would have still got the -2 and the +2, but you would have missed this 0 solution. Okay, so you can only divide by x if it's not 0, which means that 0 was actually a solution to the original equation as well. Okay, so you want to be careful about that if you try to do it that way.